So we're going to spend 3 classes on 6.3, learning about domain and range. On Friday, you guys are going to have a quiz on 6.1 to 6.3. So that'll be happening Friday. So 6.3, we're talking about domain and range. So we're going to understand the meaning of domain and range and see the different ways that we can be expressing the domain and range of a function. So on the next page on the left, the domain is a set of all possible values for the independent variable in the relation. Remember, the independent variable is the one that comes first in a table or in a set of ordered pair or on a graph there along the x-axis. Or if it's an equation with one variable by itself, the independent variable is usually the one that's inside the equation, not the one that's by itself. So generally we say that the domain are all the x values that belong to a relation. What about the range? Brooklyn? So it says on the left, it's a set of all possible values for the dependent variable that belong to a relation. So that is the y value, the second set of numbers in the table, or the second set of numbers in the uh, ordered pairs, or it's the ones that are along the y-axis or vertical axis of a graph. So generally we say that the range will be all the y values that belong to a relation, where the domain are all the x values that belong to the relation. So as it says there, if you have a set of ordered pairs, the domain are the first element of each pair, the ranges are the second element. On a graph, the domain's plotted along the horizontal or the x-axis, where the range is plotted along the vertical or the y-axis. There's a variety of ways to express the domain and range of a relation. You can use words to describe them. For example, the domain is a set of all real numbers between 0 and 10 inclusive. So that tells us a couple different things. Real numbers are all fractions and decimals. Repeating decimals, terminating decimals, decimals that don't repeat or terminate, as well as all our integers. Then it says they're between 0 and 10. And then the word inclusive means that the 0 and 10 are also part of that. So every number between 0 and 10, all the fractions, all the decimals, including 0 and 10. That's what that means. So they use words there to describe the domain. The range is a set of all real numbers greater than 20. So again, when it says real numbers, that means all the fractions, all the decimals. And then it says greater than 20, not equal to, so 20 is not included. But every number greater than 20, all the fractions, all the decimals, all the integers are part of that. So there's two examples of using words to describe domain and range. We can show domain and range on a number line. They give a picture of the values that are allowed. For example, that number line represents all numbers between 0 and 10 inclusive. The fact that the dots are colored in means that those values are included. If you have a circle instead of a colored in dot, it means that the values are not included. Okay? And I think we saw that when we did some of our review at the start of the course when we reviewed inequalities. This number line represents all numbers greater than 20. So an open dot on the 20 means that 20 is not included. And then you got a line with an arrow on the end of it, meaning it goes forever to the right. That shows all numbers greater than 20. That next number line oh, looks like I kind of froze here. Oh, there we go. So this next number line represents discrete list of numbers. Remember, discrete data is where you're just looking at individual numbers, not all the values in between. Those number lines above show continuous data because it's all numbers between 0 and 10 inclusive, or all numbers greater than 20, all the fractions, all the decimals. But this last number line just shows discrete data. Only the numbers -2, 0, 4, 8, and 10 are colored in. So only those values are part of that relation. And that could be showing the domain or it could be showing the range. Okay? Either or, it doesn't matter. You can use number lines for both. Sometimes we use a list, and that is only used when the domain and range involves discrete data. So remember, a discrete graph is where you only have points, they're not joined. So when you have that, you can give the domain and range as a list. So for this example, we've got a table, or I should say a set of ordered pair. There are 4 points there. The domain are just the x values, the first numbers in the ordered pair, 0, 1, 3, and 5. That's your domain. Your range would be the y values, or the second numbers in the ordered pair, 0, 5, 7, and 7. And notice you don't have to write both 7s there. Okay? 2 of the points have a y value of 7, but you don't have to write them both when you give the range. You can, it's not wrong, it's just not necessary. Set notation is a formal mathematical way to give values of domain and range. So this statement here uses those squiggly brackets. Those are the types of brackets that we use for set notation. That funny looking E means is an element of. The line between the two X's means such that. So this statement is read as X is an element of real numbers such that X is less than or equal to +10. Or if you read from what it says here from left to right, we would say all values of X such that X is less than or equal to 10 and X is an element of real numbers. So that means all numbers, all fractions, all decimals, because that's what real numbers tells us, that are less than or equal to +10. And then this other statement here, this shows a range, and this is how you would read it. All values of y such that y is greater than 20. And again, y is an element of real numbers. So that's all fractions, all decimals greater than 20. So these examples both involve real numbers. So that's one of the most common ones used, but also we will use integers as well. Integers are not fractions or decimals. They're just positive and negative counting numbers. So we will see some examples where we're going to use integers. The last one is interval notation. It uses different brackets to indicate an interval. When a square style of bracket is used, that means the end number is included. When a rounded bracket style is used, the end number is not included. The symbol infinity is used when there is no endpoint. So if we wanted to show a domain of all numbers between 0 and 10 inclusive using interval notation, remember the word inclusive means that the 0 and 10 are included, and that's why the square brackets are used. When you use interval notation, it's always the lowest value to the highest value, always. So this next example, the range of all numbers greater than 20. Remember, if it just says greater than 20, it means that 20 is not included. So that's why we have a rounded bracket on 20. And all numbers greater than 20 means you're going up to positive infinity. And infinity can never be included, so again, you need to use a round bracket there. There's a couple more examples. The domain for x is less than 5, where x is an element of reals. So remember, you're always going from smallest to greatest. So you're going from 5 down to negative infinity. But when you use interval notation, it's always smallest to greatest, which means you have to have the negative infinity first, comma, 5 second. And the rounded brackets are used because those end values are not included. And if we were told that the range is all real numbers, well, then you're going from negative infinity to positive infinity. Again, smallest to greatest, and round brackets are used because you cannot include ever infinity, whether it's positive or negative. So we're going to use mostly either set notation or interval notation. Those are the last two that we talked about, but there are the other ways that we can express domain and range as well. But remember, when you're asked for the domain, it's all the x values. When you're asked for the range, it's all the y values. So in this example, it says, give the domain and range. Use words, a number line, interval notation, and set notation for each. So for that first graph, if we want the domain, those are the x values. X values go left and right on a graph. So we want to know how far left the graph goes and how far right the graph goes. So we can use a couple different ways to help us do that. One of them is to actually draw a number line connected to this graph. If we want to know what the domain is, again, we want to know how far left and how far right the graph goes. This graph goes as far left as this point up here, which corresponds to a x value of -6. And because there's a closed dot on there, that means the -6 is included. So I put a closed dot directly below that dot, directly below the graph. And as I move downwards on this graph, I'm also moving to the right. And I'm going to go to the right as far as +3. But there's an open dot on there, which means that that +3 is not included. Every value between -6, which is included, and +3, which is not included, belongs to the domain. The domain is asking for the x values on a graph that wants to know, does the graph go left, does it go right, how far? This graph goes as far left as -6, which is included, and as far right as +3, which is not included. So if we wanted to write the domain in words, it would look something like this. We would say all real numbers between -6, which is included, and +3, which is not included. There's the domain in words. Now, for the range are the y values. Does the graph go up? Does it go down? This graph goes up as high as +5 on the y-axis and down as low as -4 on the y-axis. The +5 is included because of the closed dot up there, but the -4 is not because of the open dot. And again, the fact that those 2 points are connected with a line means it's continuous data. It means that we're going to have all real numbers between -4, which is not included, and +5, which is included. So there's the domain and range for that first graph in words. So now let's do it on the number line. On the number line, for the domain, we're going between -6 and +3. The -6 is included, so that's a closed dot. The +3 is not, so that's an open dot. And we have a line in between them. So there's the domain on the number line. The range goes between -4 and +5. The -4 is not included, so that's an open dot. The +5 is, so that's a closed dot. And again, we have a line in between there. Using interval notation, remember you always go from smallest to greatest. So -6 on the left to 3 on the right. The -6 is included, that's a square bracket. The 3 is not, so that's a rounded bracket. For the range in interval notation, you're going from -4 up to 5, always smallest to greatest. The -4 is not included, that's a rounded bracket. The 5 is, that's a square bracket. And if we're going to use set notation for the domain, that involves the variable x. All values of x such that we would say that x is greater than or equal to -6, but only less than 3. And again, because it's a line, that means x is a real number. X belongs to the set of real numbers. The line between the 2 points tells us that it is continuous data. All fractions, all decimals, as well as all integers are part of that domain. And then the range uses the variable y, so it's all values of y such that here y would only be greater than -4, not equal to, but it's less than or equal to +5. And again, y is an element of real numbers. The fact that there's a line between those 2 points on the graph tells us that it's continuous data. All fractions, all decimals, all integers, which means we're using real numbers. So there's domain and range for the first graph using all 4 ways of expressing. Looking at the second graph, that's a circle. Okay, the domain are all the x values. It starts at +1, which is included, and goes up to +7, which is also included. All values in between are part of that relation. So if we're going to write the domain in words, we would say all real numbers and in this case we can say between -4 and +1 and 7. And then if we say inclusive, that means both n values are included. That's what the word inclusive means. The range goes down to a minimum value of -3 up to a maximum value of +3, and all values in between are also included. So we would say that the range would be all real numbers between -3 and +3 inclusive. Using the word inclusive means, again, that those n values are included. On a number line, we'll go from 1 up to 7 for the domain. The n values are included, so that's a closed dot and a line between them. The range goes from -3 to +3. Again, they are both included, so closed dots and a line in between. Interval notation. Remember, it's always smallest to greatest, and because both n values are included, we use square brackets for the domain and the range. Smallest to greatest, square brackets because the n values are included. Set notation. Remember, the domain involves the variable x, all values of x such that we would say x is greater than or equal to 1, less than or equal to 7. And again, it's all real numbers because the line is between the points. All fractions, all decimals, all integers between 1 and 7. Our range uses the variable y, all values of y such that y is greater than or equal to -3, less than or equal to +3. And again, y is an element of real numbers. So you're going to be tested on this. We're having our first quiz on this stuff on Friday. You're going to have to be able to determine domain and range for from a graph and state it in all these different ways. Words, number line, interval notation, set notation. Okay? So we're going to do the same thing for these two graphs. Let's first look at the domain for this first graph. It starts at -2 on the x-axis, which is not included. And as this graph is going upwards, it's also going to the right forever. So it starts at -2, which is not included, and goes to the right forever. For the range, the y values, it starts at -3 on the y-axis and goes upwards forever. So if we want to write these in our different forms, the domain for A would be all real numbers, because it's a line. That means it's continuous data. It means all fractions, all decimals, all integers, all real numbers greater than -2. There's the domain written in words. The range will be all real numbers greater than -3, because that's the starting point of that graph along the y-axis. But it's only greater than -3 because that open dot means that the -3 is not included, just like the open dot means that the -2 starting point for the x values is not included. Okay, so on a number line, we would start at -2 with an open dot, and we would have a line going off to the right with an arrow on it. On the number line, that shows all numbers greater than -2. And for the range, we would start at -3 with an open dot and a line going to the right with an arrow on it. Interval notation, remember you always go from smallest to greatest. In this case, it will be -2 up to positive infinity. The -2 is included, so we need a round bracket on that. Infinity is never included, so we also need round bracket. Same thing with the range. It goes from -3 to positive infinity. We need round brackets on both of those. And finally, our set notation. Remember, the domain involves x, all values of x, such that we can just say x is greater than -2. And x is an element of real numbers. It's real numbers because the graph is a line, which means continuous data. All fractions, all decimals, all integers greater than -2. That's what real numbers are. And the range uses the variable y. Here it'll be y is greater than -3. But also y is an element of real numbers. Okay, so that's for that graph. Graph B, a little bit different. It starts on the y-axis where x is 0. Now notice that you have an open dot up here, so x equals 0 is not included up there, but the closed dot here means that it is included. So even though 0 is not included up here as an x value, it's included down there. And it goes as far right as +5, which is also included. The range starts at a minimum value of +2, which is included, up to a maximum of 7, which is not included. So when we're talking about the range, that open dot at the top will factor into it. So again, this just is a kind of a graphical way of getting the domain and range from the graph. You don't have to do what I've done here, but you might find it useful. So the domain will be all real numbers again, because we've got the line between these 2 points. All fractions, all decimals, all integers between x equals 0 and x equals 5. So we would say all real numbers between 0 and 5, and that would be inclusive. And if I just continue down and finish off the rest of the domain, I'm going from 0 on the number line to 5 on the number line. They're both included. So that's a closed dot. And we have a line in between them. That shows all real numbers between 0 and 5 inclusive. Interval notation. The 0 is included as well as the 5, so we use square brackets. Remember, it's always smallest to greatest. Set notation. All values of x such that x is greater than or equal to 0, less than or equal to 5. And again, because a line is being used there, that's continuous data, which means real numbers. X is an element of real numbers. For the range, we went from a minimum of 2, which is included, to a maximum of 7, which is not. So we would say all real numbers between 2, which is included, and 7, which is not included. So on the number line, always smallest to greatest between 2 and 7. The 2 is included, so that's a closed dot. The 7 is not, so that's an open dot. Interval notation, again, smallest to greatest. The 2 is included, that's a square bracket. The 7 is not, that's an open bracket. And when we write the range, the variable is y, all values of y such that y is greater than or equal to 2, but only less than 7. And again, y is an element of real numbers. So again, Friday, you're going to be testing all of this. Not only knowing what the domain and range is, but also being able to express it in these different ways. Words, number lines, interval notation, and set notation. This next example, domain and range for a real situation. The Great Wheel, at the point when this book was published, was being built in Beijing, in China. When it finished, it would be the largest Ferris wheel in the world. It will have a diameter of 193 meters, reach a maximum height of 208. The graph shows a rider's height relative to the ground for a 20-minute ride through one rotation. What are the values of points A, B, C, D, and what do they represent? And then what is the domain and range of the graph? So, A is the maximum height, which we are told is 208. We are told that. We are also told that the diameter of the wheel is 193 meters, which means the minimum point, the low point, would be 193 meters below 208. So that's how we get B. We take the 208 and we subtract 193. And that gives us a difference of 15 meters. So down below, again, A is 208. That is the maximum height. B is found by, again, taking the maximum height and subtracting the diameter. So that is 15 meters. C is times 0 when the ride starts. This is the start of the ride. Right? When people get on a Ferris wheel, they get on at the lowest point. And then D will be how long it takes to go through one cycle, which we are told at the top is a 20-minute ride through one rotation. So D is 20 minutes, which is the time for one rotation. Remember, the domain is measured along the x-axis. So that's between C and D inclusive, which means between 0 and 20. So there's different ways that we can express this. Probably the easiest would be interval notation. We're going from time 0 up to time 20, and both are included, so we use the square brackets there. Whenever you use interval notation, that means, princess, that means real numbers. Okay, we're going to look at some examples with discrete data. You cannot use interval notation there. Okay, you only have a couple options with discrete data, one of them being a list. Sometimes you can use set notation, but only if the numbers are sequential, meaning 1 to 2 to 3 to 4, can't have any missing numbers. Otherwise, it's a list. The range, well, that's measured along the y-axis. This height has a minimum height of 15 and a maximum of 208. So using interval notation, smallest to greatest, those two numbers are included, which means square brackets. All heights between 15 and 208 meters are part of this. All fractions, all decimals, all integers. So it's all real numbers between those two values, which means we can use interval notation. Okay, on the next page. So now we'll look at an example where we have discrete data, not continuous. Caitlin is marking time for some music by clapping on the first beat of every bar. Table of values instead of ordered pairs show the relationship between the number of beats and the number of claps. So for one beat, there'll be one clap. For 5 beats, that's your second clap, because the beats are the first beat of every bar. Okay? So we're seeing then that X is increasing by 4, and the number of claps is only increasing by 1. So from the table of values, we get our ordered pair. And again, this is discrete data because you're not going to have half of a clap. You're also not going to clap on the second part of the what do they call it? The bar. Yeah, the first beat of every bar. So you're not going to clap on the second beat of the bar or the third. It's only every fourth. Okay? And that's why these are going up by 4 along the number of beats. So if we want to give the domain and range using words and a list. So for the domain, that's the first numbers, which are 1, then 5, then 9, then 13, and so on. So as I said earlier, they're going up by a constant rate of positive 4 every time. So if we want to use the words for the domain, we would say, starting with 1, and then every multiple of 4 up to 29. So starting at 1, if you add 4, you'll get 5. Adding another 4, you'll get your 9. Adding another 4, you'll get your 13. And that pattern continues all the way up to 29. So there's the domain in words. As a list, when you're doing a list, it's like set notation. You use those squiggly brackets. And a list is just listing all of the different numbers that belong to that set. You can always express discrete data with a list. You can't always, though, do it in words because there's not always a pattern like we have here. So there's the domain in words and as a list. The range, we could express this in words. We could say all integers between 1 and 8 inclusive. If you start at 1 and you go up by integers, which are just positive counting numbers in this case, you're going to go up to 8 and not miss any of those numbers that are there. So we could say all integers between 1 and 8 inclusive. Now, because they are consecutive integers, you could also do this using set notation for the range. We could say all values of y such that y is greater than or equal to 1, less than or equal to 8, and we would say y is an element of integers. Instead of real numbers, we would say y is an element of integers. So we did the range in words. We can also use set notation here because they are consecutive integers. Or we can use a list by just listing all the numbers. The first example, though, the domain, you cannot do using set notation because it's not consecutive integers. So you see the difference between those two. You also cannot use interval notation for discrete data. You cannot. As soon as you use interval notation, you're saying that the data is continuous. All fractions, all decimals are part of that relation, and that's not true for discrete. So for this table, we're asked to give the domain and range using set notation and a list. So the reason you can use set notation is because they are consecutive. So for our domain, using set notation, we could say all values of x such that x is greater than or equal to -3, less than or equal to 2, and x is an element of integers. As a list, we just write them out. And then for our range, again, we are allowed to use set notation because they are consecutive integers, one after the other. The difference, though, is that we're using the variable y. Y is greater than or equal to 5, less than or equal to 10, and again, y is an element of integers. As a list, we just list them. Okay, so we're going to stop there for today. You should be working on these questions. I will post the solutions to this on Google Classroom so you can check your answers. We'll do some more of this tomorrow, and tomorrow's assignment will be due for marks. So do the practice now so that you're better prepared for the one tomorrow that's going to count for marks. And remember, you're going to have a quiz on everything that we've learned so far in this chapter, including what we're talking about these next 2 days, domain and range. That quiz will be on Friday. Yes. Yep, make sure you sign out. Okay, so those questions need to work on. Yes. Yeah, make sure you sign out.